Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P15C5, indicates a low voltage characteristic in the brake booster pressure sensor A of the Honda Pilot model years 2016 through 2022. This error suggests that the sensor responsible for monitoring brake booster pressure is not functioning within its normal voltage parameters. The brake booster pressure sensor plays a crucial role in ensuring adequate braking performance by measuring the force applied to the brake booster. It is typically located on the brake booster assembly, which is attached to the master cylinder. Proper functioning of this sensor is vital for the anti-lock braking system, ABS, and overall vehicle safety. When this DTC is logged, it requires immediate attention to prevent compromised braking functionality. The brake booster pressure sensor A is a vital component that measures the pressure exerted on the brake booster, which in turn assists in applying the brakes effectively. It is primarily located on the brake booster assembly, which is usually connected to the master cylinder in the engine compartment. This sensor uses electrical resistance to monitor the brake booster pressure and conveys this information to the engine control module, ECM. The ECM then utilizes this data to determine the necessary adjustments needed for optimal braking performance, including adjustments in the fuel injection and ignition timing to enhance safety. If a low voltage characteristic is detected, it might indicate an issue either with the sensor itself or the vehicle's powertrain control module, PCM, necessitating thorough diagnostics. When diagnosing DTC P15C5, there are several potential causes that may lead to the low voltage characteristic being recorded. The first likely cause is a faulty brake booster pressure sensor A, where the sensor may be defective or failing, thus providing inaccurate voltage readings. Next, wiring issues should be examined, as damaged or corroded wires can interrupt the sensor signal or cause voltage drops. Finally, another consideration is the possibility of a malfunctioning powertrain control module, PCM. The PCM may not be properly interpreting signals from the sensor, which can cause erroneous DTCs. Each of these factors should be thoroughly checked during the troubleshooting process to ensure a complete repair. The symptoms associated with DTC P15C5 can range from minor to severe, impacting overall vehicle functionality. A primary indicator is the activation of the brake system warning light on the instrument panel, which can alert the driver to potential issues with the brake system. Additionally, inconsistent braking performance may be observed, where the brakes may not engage properly or respond as expected, potentially leading to safety hazards. Another concern is poor vehicle acceleration, as braking pressure could be regulated improperly, affecting engine performance. Therefore, recognizing these symptoms can assist in diagnosing the underlying problem effectively and ensuring prompt repair. In the first troubleshooting step for DTC P15C5, it is crucial to check any powertrain management fuel injection PGMFI Diagnostic Trouble Codes, DTCs, before proceeding with further diagnostics. Begin by turning the vehicle's ignition to the on position without starting the engine. Once the vehicle is in this mode, utilize the Honda Diagnostic System, HDS, to scan for any pending or confirmed DTCs. This preliminary check is necessary because other codes could potentially affect the performance of the brake booster pressure sensor. If any additional DTCs are indicated, those must be addressed first, as they may be directly related to the braking system's function and could skew the troubleshooting efforts for code P15C5. After confirming no other DTCs are present, the next step is to specifically examine the brake booster pressure sensor. Begin by turning the vehicle's ignition to the off or lock mode to ensure safety while working on the sensor. Remove the existing sensor and substitute it with a known good brake booster pressure sensor for testing purposes. Once the replacement is installed, turn the ignition back to the on position to power the system. Next, clear any previously stored DTCs using the HDS. This process resets the system, and it will allow for a fresh diagnostic runtime that enables accurate monitoring of the new sensor's performance. Once the known good brake booster pressure sensor is installed and the DTCs have been cleared, utilize the HDS to check for any new or continuing DTCs. This scanning is important to monitor the operation of the substitute sensor and verify whether the low voltage characteristic persists. Keep an eye on the readouts during this scan to assess the brake booster sensor's functionality accurately. If DTC P15C5 is still indicated, it points towards a more complex issue, possibly within the vehicle's powertrain control module, PCM. Alternatively, if no DTC is shown, it confirms the replacement sensor is functioning normally. If DTC P15C5 is still active after replacing the brake booster pressure sensor, the next course of action involves substituting a known good powertrain control module, PCM. This module is critical as it manages and processes sensor input signals, including those from the brake booster pressure sensor. Make sure to disconnect the original PCM and connect the replacement carefully, ensuring all wiring connections are secure. Once the new PCM is installed, scan for DTCs again with the HDS to assess whether the issue persists. If the DTC no longer appears and braking performance improves, it indicates that the original PCM was faulty and should be replaced to restore proper function. The final step in the troubleshooting and repair process is to conduct a thorough verification to ensure that no DTCs remain in the system after all repairs are applied. This involves a complete scan with the HDS to confirm that DTC P15C5 has been cleared and does not reappear. After ensuring the diagnostic system shows no error codes, it is crucial to test the braking systems under various driving conditions to ensure they are operating within safe parameters. Also, keep an eye on the brake system warning light to ensure it doesn't reactivate. This final verification is essential in assuring that the vehicle is not just operational, but also safe for use. In conclusion, diagnosing and resolving DTC P15C5 involves a systematic approach that includes checking for other DTCs, assessing the brake booster pressure sensor, and verifying the powertrain control module, PCM. Each component plays a vital role in ensuring braking performance and vehicle safety. By systematically following the outlined troubleshooting steps, replacing faulty parts, checking wiring, and confirming all systems are functioning correctly, technicians can restore reliability to the braking system. This ensures that drivers face no unexpected braking failures, thereby enhancing overall road safety. Regular maintenance checks can also help preempt issues like the P15C5 code from arising in the first place. Please like and subscribe to the channel. See you next time.